Okay, so we have a histogram. Shows the ages of the women at the library one Tuesday. So apparently they only counted up the women. Approximately how many women were younger than 40? Well, let me come over and read this first. And typically what I like to do is I like to write numbers on top. Like if I look 20 to 30, how many women are counted there? One. And then 30 to 40 is 3, right? And then 40 to 50 looks like 7, 9, 12, back to 7, back to 3, and back to 1. Okay? So when it says approximately how many women were younger than 40, I find 40, that's this boundary right here, correct? And to the left of that boundary would be less than 40. 3 plus 1 is 4. Okay? If anyone 60 or older gets a free gift on Tuesdays, how many will get the free gift? Well, 60 or older. 60 is this boundary right here. So I'm going to cover up everything here. This would be all the 60 or older people. So 12 plus 7 plus 3 plus 1 is 23. How many women were there in the library altogether? Or were there at the library? 1 plus 3 plus 7 plus 9 plus 12 plus 7 plus 3 plus 1 is 43. Is this data skewed to the left, right, uniform, or symmetric? Well, I can definitely eliminate uniform, right? It's not uniform. Skewed to the left, skewed to the right. The biggest thing that people did was they said it was skewed to the left, which, okay, I can kind of get that, but generally this is pretty bellish. This is pretty bellish. You don't have, like, you want to see a little bit more of a tail if you're looking for something that's skewed. So we would say that this one is approximately symmetric. Okay. What does the skew or symmetry tell us about the ages of the women who use the library? Well, I had some interesting conclusions. I had some people that said things like old women tend to use the libraries on Tuesdays. Well, okay, first off, other than the fact that that's kind of offensive, but this is just one Tuesday. Can you therefore conclude this is true for all Tuesdays? Not necessarily, unless you had a couple Tuesdays worth of data. Okay, this is just one day that we're looking at. So on this particular day, I would say something about it looks like women that are 60 to 70 are the most represented in the library on that day. Okay, some kind of a conclusion to that effect. Okay, or you could say on this particular Tuesday, there's not many young women and not many elderly women. Most of the women seem to be kind of middle-aged there. Okay? Some kind of a conclusion like that. Try not to be offensive with the wording. Some people are offended when you call them old. Elderly might be a little more politically correct. I don't know. Anyways. Yeah, there were so many different... I'm trying to see if I have any other examples of what people wrote. Women between 50 and 70 years of age mostly go to libraries. Anyone older or younger lessen the chance. I kind of get where they're going, but reread your sentence, because between 50 and 70, that's not saying that all women between 50 and 70 go to the library, right? That's not a conclusion about women between 50 and 70 years old. That's a conclusion about the library, right? We're not talking about all women ages 60 to 70 or 50 to 70, because that's like 20 people there, right? That's obviously not the whole population of that area. So make sure that you keep it in context also, that you don't make a generalization about a group of people when you're really just looking at a small group that's not a representative sample. Okay? All right, the data listed is on the number of phones in 20 households. There's my data. Make a line or dot plot of the data. Make sure to label your axis with words and numbers. Now, on the test tomorrow, test is on the computer, right? You'll have to make sure to read instructions carefully because it will ask you about the skew and all that kind of stuff, and then underneath that it will say draw the dot plot on your answer page. In which case, I have provided the place for the dot plot. No, I have not. That's a lie. This is the box and whisker plot. The dot plot, let me backpedal a little bit. The dot plot is actually on the computer. There's a number line there, and you just go mark them on there. You just click where you want them to go. Okay? So, I'm going to label this. The smallest number I think is 0. And these are all numbers that it seems like I could count by ones, right? 1, 2, 3, 4, 5. I don't know if I'm going to have any 5s, but 3, 4, 4, 0, 3, 2, 4, 3, 2, 1, 3, 3, 2, 4, 4, 3, 4, 3, 1, 2. Well, you should have ended up with 1 in this column, 2 in this column, 4 in this column, 7 in this column, and then 6 in that column. And again, you can use X's or dots. Now, if I look at this one to me seems like it has a definite more of a tail this way because it doesn't come down on this side like the one up here did, right? These ones, both sides came back down. This one, we got nothing up here. So I would say this one is skewed left. So? All right, next one. The mean grade on a final exam was 72%. I see a number. For the 370, I see a number. Students enrolled in IM3, a class of 35, I see a number. IM3 students had a mean exam score of only 60, I see a number. Describe the following words and numbers if possible. How many numbers did I circle? 4. How many things am I looking for? Each one's a number. Yeah? I always start with the population because I think that's the easiest. The population's the biggest group. That would be your 370 IM3 students. Right? Or all students enrolled in IM3, something to that effect. But you can put a direct number with it. If you can put a number with it, do it. Then what's the sample?
35
So population is always the big group, sample is the small group. Then we get into the actual pieces of data that we have, the 66% and 72%. The percentage that talks about the population is which one, 72 or 66? 72. That's your parameter. Population always goes with parameter. P goes with P. The statistic then goes with your sample, and that's the number that deals with the sample results, which would be your 66%. Questions there? Reasonably easy, yeah? All right, the box plot. Show the number, the box plots show the number of computers sold per month for 2 stores. Estimate an interval for store 1 that represents 75% of the data. Now, when I say estimate, when you say min and Q3, that's not an estimation. That is an interval, but it's not an estimated interval. That's an exact interval, right? So when it says estimate, I'm looking for that value. To me, looks like, what, 25-ish?
Yeah.
Some of you put 30, 25, 20, somewhere in that range, right? And then 75% needs to include 3 parts. So here's 25%. Here's 25%. Here's another 25%. So the end of 75% would be up here, like, what is that? Maybe 410, somewhere around there? Yeah? What's another option you could have for that one? Well, you could do from here, which looks like about, what, 180-ish? Because this is also 25%. You could do 180-ish to, oh, what would that be? 570-ish? So either one of those ranges were reasonable guesses. The big thing with those ones is make sure you're looking at store 1 as opposed to store 2. Yes?
Would it be reasonable to say instead of 410, 425?
Yep. Yeah, I'd probably give it to you, but it's definitely not 425 because this is 400, that's 450, 425 would be directly in the middle. It's close enough. I mean, it's obviously an estimate. It's somewhere, you're in the ballpark there, so. Okay. Questions there. Which store, 1 or 2, has the smaller IQR? Which one? Why? Box is smaller. Remember, the IQR is the length of the box. So the smaller IQR is going to have the smaller box. Okay? All right, you want to find out more about the families of the students in your class. Write one question you could ask each student if you wanted categorical data. Now, so many people focus on the fact that this is categorical that they forget that you should to read the rest of this. Because they'll ask a question like, they'll phrase it such as, what are people's favorite movie to watch with their family? Yes, that's categorical, but if you had a survey that asked you individually, what are people's favorite movie? You can't answer that because you don't know. That's the whole point of the survey, right? You would want to phrase it like, what is your family's favorite movie to watch? Because that you can answer. Does that make sense? So a lot of people asked, what did people ask on that one? They asked about, what was that? Pets. That was a common one that I saw. So what kind of pet does your family have? That's the only thing you can give me a truthful answer on. I can't say what kind of pets do families in this class have because you're just going to be guessing when you, well, I assume they have dogs, maybe some cats, maybe a bird here or there, or fish. Okay? All of that is just guessing, right? You can only answer about you specifically. So you want to make sure if you're giving a survey that you write the questions as though that was the case. Then the other part, the categorical, has to be a word answer, not necessarily numerical. Okay? If you wanted numerical data, most common one I saw was something like that. How many people are in your family? Now, if you were really giving a survey and actually wanting to collect data, you might want to be more specific than that because some people count their grandmas and their grandpas and their aunties and uncles and whoever else. You might want to say how many people live in your house or how many people are members of your household, something like that. You want to be specific about what it is you're trying to get. Explain whether you would take a census or a survey and why. Well, let's see. We're looking at families in our class. Could you find information about our entire class? That's a reasonable population, isn't it? Not a ton of people. It's a lot, but it's not a ton of people. It's not like you have to pay money to make copies to send it out to people or whatever. It would be fairly easy to do that. So if you can and it's reasonable, you would want to take a census. Because small enough population to make it easy, something like that. Okay, so? All right, let's turn it over. All right, use the sample data set right here to identify the following: mean, median, mode, range, standard deviation. I'm going to first off put them in order. You don't have to, but it's going to be easier when I get down to median and 5-number summary, etc. So there's 1, what is it, 4, 4, 4, 5, 8, 8, 10, 10. Now again, I always want to go back and make sure I have all the numbers, because if I don't have all the numbers, we're going to have issues in most of this stuff. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, for the mean, I think everybody got that. You do, I'm going to write out the steps just because this is the group test, and that way if there's ever any questions. So 1 plus 4 plus 4 plus 4 plus 5 plus 8 plus 8 plus 10 plus 10, all divided by 9. That's our mean, and it ends up being? Okay, and again, it should be somewhere relatively around the middle of your data, which is reasonable. Median, what is exactly in the middle of my data? 5, that's my median. Mode, what number is most popular? There's no work to show for those. Range, biggest number minus smallest number, range is 9. And then the standard deviation. So this is the one where you have to do 1 minus your mean squared, and then 4 minus your mean squared, 4 minus your mean squared, 4 minus your mean squared, 5 minus your mean squared, 8 minus your mean squared, 8 minus your mean squared, 10 minus your mean squared, 10 minus your mean squared. And you're going to add all those up. Does anyone know what it is when you add them all up? I don't have that written down. 78. Divide by 9 minus 1 and take the square root, and you end up with about 3.12. Give me like 2 digits past the decimal. There's good. Okay. So yes, that's the one that's going to take a little bit longer than the other ones, but it is what it is. All right. Part F, 5-number summary and box and whisker plot. First thing, see this is labeled max. I need to label the rest of them. What's the first one? Min. And then Q1, Q2, Q3. What's the minimum value? What's the maximum value? And what's Q2? 5, because that's my median, correct? Now, once I've used 5, I take 5 off the list, and I need to find Q1 by finding the median here. Well, the median here is right between those two. What's between 4 and 4? 4. That's Q1. And then Q3 would be the median here, which would be 9. Before I do the box and whisker, what's the IQR? And how do I find that? Q3 minus Q1, which is 9 minus 4. Okay? Now, this is the one that I showed you on your answer page, your box and whisker plot. You're going to need to put the labels underneath here. Okay? I think I have it set up so you can count either by 1s or 2s. Okay? So, try and be nice like that. This one I think I can pretty clearly count by ones. I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The minimum is at 1. And then 4, 5, 9, 10. Connect those 3 middle boxes. And then draw your whiskers on the ends. And again, it's just helpful if you put those numbers up above to finish off your box and whisker plot. Now, let me show you a couple box and whisker plots that I got that I just want to point out some issues with it. Here's one. You can see I wrote on it. I prefer your box and whisker plot physically above the number line. Otherwise, it's hard to read your whiskers. Do you see that? So make sure they are above your box and whisker plot. What was another one that I saw? I wanted to show. Is it that one? No. Would it be wrong what?
To not start at 0.
No, that is totally fine. You can start at 5 if you need to. Just show the area that you need to show.
Okay.
This one. Boxes are good. Whiskers have no end point. They just drew the whiskers there. They didn't stop at the minimum and the maximum. Okay? So just be aware of those things. Those are things that people can make mistakes on and end up losing points for. Okay? All right. Last set of problems. We have options. We have self-selected, systematic, simple random, stratified, cluster, and convenience. Let's refresh our memories here. What is self-selected? People volunteer to be a part of it. Sometimes it's called a volunteer sample, I think, or volunteer selected. Systematic. There's some method. Every second person, every fifth person, every 20th person. There's a method to it. Simple random. All the names in a hat. Totally random. Stratified and cluster. What's the difference between stratified and cluster? In both cases, they're split up into groups, right? Stratified is taking a little from each group, whereas cluster is just picking a few groups and taking those whole groups. And then convenience, asking the people that are easiest to ask, right? So, you want to know how many people in your art class have a car. You ask to see the attendance roster and ask every fifth person. That would be? Now, usually I'm not a stickler on spelling, but somebody accidentally put symmetric there. I do have to mark that wrong because symmetric is not a type of sampling. Okay? All right, you want to know how many people have a car. You pick 2 table groups to ask, and you ask everyone at those tables. Cluster. What are the groups? The tables. And asking whole groups would be cluster. You want to know how many people have a car. You ask 3 sophomores, 3 juniors, and 3 seniors. Stratified. You have your groups by sophomores, juniors, seniors, and you're taking a few from each group. You ask 7 people who sit near you. Those are the most convenient people to ask. You want to know how many have a car. You put your Twitter handle on the board and ask the class to direct message you their answer. What would that be? Self-selected, because only those that choose to participate will reply. And then you put all the students' names in a bowl and pick 8 students to complete your survey. Simple, random. Okay. Any questions? Who's getting 100% tomorrow? I'm hoping to have a lot of 100% tomorrow. Yeah? All right. My job's done. Happy studying. Oops.
That's what I'm thinking.
Oh my goodness.